headed in to take a look at a walk-in freezer that apparently is warming up, so we'll see. Okay, so we're on site. Just pulled over here by the unit. This feels kind of cold. Condensing fan motor is running, but I do not hear the compressor running. That's a really bad sign. That likely means that the compressor has failed. Hopefully not, but possibly. We're gonna check out the start components first. Okay, so that's kind of good. It looks like that start capacitor exploded. So we're gonna kill the power to this thing. So you can see this red wire, which goes over to the compressor, is completely burned off. I say that's a good sign because our compressor is not running. So this connection might have just gotten loose, causing this start capacitor to definitely explode. You can see there's like nasty burned, melted, spider webby type stuff. But that means that likely as long as our relay isn't leaving this thing in circuit for too long, then we should be fine. So figure out how many microfarads it is and get our new one hooked in there and fix that bad connection and then turn it on again. Okay, so I pulled the capacitor out of the circuit, just those two wires there. Make sure when you pull these out you first ground them. Ground those terminals to the body of the unit so that if there's any charge it is dissipated before you pull it out. This one has a bleed resistor, but you don't want to rely on that. Now you look on here, it says 145 to 174 microfarads, 250 volts. We've got our meter put into the scan mode, which one of the things it measures is microfarads when it's in the scan mode. And we're just going to go ahead and check across there. Well, not surprising to get nothing from something like this. 0.87 microfarads, so this thing is definitely bad, so we're going to get a new start capacitor. Second thing we're going to look at is the run capacitor. Should have 45 microfarads between those two terminals. I've disconnected this wire from here. I'm just going to mark these two, both of the black lines, so that we know those two go together on one side of the capacitor, and we'll unhook them. Again, grounding that out into the unit, so we know we're good. Well, and it would appear that the run capacitor is also bad. So there's the common terminal, the fan terminal, and the Herm terminal. So we're just gonna go from common to Herm. Yeah, we're only getting nothing. So this capacitor is also bad. So we have two bad start components and a burnt off wire. So we're gonna go get new start components. Hopefully I have both of those capacitors, and then we're actually just gonna cut this nasty section off and then clamp it securely into there and skip using one of those connectors, because I find that they typically last better if they're actually clamped underneath the screw instead of using a connector. But you could use a connector. So here's the motor start capacitor that I have. Unfortunately, this one is not the exact same range as our original one. Our original one is that 145 to 174. This one is a 130 to 158. Since it's kind of a range, this should still be able to start a compressor. And sometimes you kind of have to do with what you have on the truck, because if we don't get this thing up and running shortly, then they're going to have a lot of product go bad. So even if we use this one temporarily, it's going to make more sense than letting thousands of dollars of food go bad. But we might actually end up ordering that exact same one and then coming back and putting it in. So we've got that, and a 45 microfarad run capacitor. You can see this one only has two terminals on it, and that's because somebody else used a dual capacitor and just didn't use the 5 microfarad, which is why it's a 545 microfarad capacitor. So this is actually the correct one, but you know, another case of what you got in the truck is what this represents. So we're gonna go ahead and put this thing in gotta hook the one here and then the two with the black lines that we added here. And then this side we're gonna add our new start capacitor. So if that relay went bad, which is possible, it might actually blow up another capacitor, but I'm thinking it's more related to that wire being burned off. See, that thing just got totally melted off. Cut this back pretty far to get rid of any of the damaged area. Doesn't really seem like any of these other wires got damaged. So I think we're ready to go ahead and fire this thing back up. Let's watch our amp draw. In case we're drawing locked rotor amps on the compressor, then we're going to want to shut this thing down right away. But we can just watch that amp draw there. In order to see locked rotor amps, we have to take this whole thing apart, so we'll just watch it and see what it does. All right, 3, 2, 1. Nice. So you can hear the compressor's running. Started up just fine. .3 amps is not too much. I'm like always a little bit nervous after we start something that had just blown up start components. But like I said before, I'm guessing it was related to that wire burning off. If it's making a bad connection, it can do all kinds of stuff. So if that start capacitor was still in the circuit, I'm guessing it would have blown up by now. So our relay is doing what it's supposed to do, which is briefly using this capacitor to start it and then dropping that back out and then using this capacitor to help run it. So I think we're gonna be okay now. It sounds kind of funny because I've got all this stuff sitting on it. I actually don't know what kind of refrigerant this thing is because the person who installed it didn't mark anything, at least out here. They might have written something on there, but honestly, I have no idea what's in this thing, so we'll have to figure that out. So yeah, line set is getting nice and cold now. We are going to order the right size start capacitor and then come back and put that in. Should actually come here tomorrow, but this will temporarily hold them through until we get that other capacitor put in, because it just doesn't make sense. All their product would go bad if this thing can't run, but it's going to work until we put in that other capacitor. But yeah, I think that just about wraps it up. We'll go inside and make sure that everything's cooling down. I think I'm actually not even going to throw the gauges on because it wasn't a refrigerant related issue at all, and I can see the sight glass is running nice and clear, so we know we've got plenty of liquid in the system. So not going to do that. But yeah, looks like we're good. Already down to 20 in here. Feels nice and cold. Also kind of wanted to see if they had written the kind of refrigerant out back in here somewhere, but I don't see it anywhere. That's why it's really important to mark the system in a lot of places so that the tech doesn't have to guess, because I have no idea. It could be 404A, 134A, R22, 408A, 409A. There's so many kinds of refrigerant, you just have to mark systems really well. It's like my biggest pet peeve. Oh well. So we have returned with the correct capacitor. You can see 145 to 174 microfarad round. Okay, so just gotta pop off the cover again. We're gonna smartly turn off the power. There we go. Off. And there's our capacitor. Just gonna. Oh, that's always so scary because when they do have some capacitance, it's scary. So with our tool grounded, we're gonna touch the terminal. Okay, looks like we're good. And that smartly unplugged both. How convenient. Here is our new one. Kind of freaks me out how they keep getting smaller. Like every year they make them a little bit smaller, I feel like. Where did that come off of? That one came off of this one. So if they just come off that easily, you want to just crimp them shut a little bit so that they don't do that again. There we go. Alright, and that means we're done. So anyway, I hope that you enjoyed this interesting troubleshooting video, and I guess we'll talk to you next time. Nice, you can see it cooled down right to -20, so we are in beautiful shape.